In this video tutorials, I'm going to tell you how I managed to study all functional groups using abbreviations, strategies, and tricks. Let's get to the main video. So in studying functional groups, what I did was that I classified them into 4 different groups to make the identification very simple. So these 4 distinct groups, or these 4 different groups, I titled it with an abbreviation going with the letter HONS, horns, HONS, with the H representing hydrocarbons, O representing oxygen containing compounds, and nitrogen containing compounds. And for the S, what do you think the S would be? I'm very sure it's sulfur that is running through your brain at the moment, but that's not the case over here. For sulfur, I titled it supplementary functional groups. That is the functional group that do not fall under either hydrocarbons, oxygen containing compounds, or nitrogen containing compounds. So I titled those ones supplementary functional groups. So this was a division for all functional groups. The group of organic compounds that falls under the category of hydrocarbons, that is this particular one, we have alkane, alkyne, and aromatic hydrocarbons. For the O parts, we have, that's the oxygen containing compounds, we have carboxylic acid, ester, ether, ketones, alcohol, and aldehydes. Now, oxygen containing compounds simply means that there's oxygen in this particular organic compounds. So that is it. That's for this particular category. Now, a very quick way to be able to remember the groups that falls under this particular category, I deduce a particular mnemonic, which is CEEKA, CEEKAA, CEEKA. So this particular one, with C being carboxylic acid, this E being ester, this one being ether, the K over here ketone, A alcohol, and the last A aldehyde. So a quick way to remember the oxygen containing compounds, use this mnemonic CEEKA. For the next group, the nitrogen containing compounds, obviously they have nitrogen in that particular compound. So we have the nitrile, the amine, and the amide. And the final group, the supplementary functional groups, we have acid and hydride, thiol, and alkyl halide. That is all haloalkanes. So this is basically what we'll be talking about in this particular video. So I'm going to give tricks for each of them, how to be able to identify that this is an alkene, this is a carboxylic acid, this is a nitrile, amine, and all that. So how to be able to identify the functional groups for each of them. So let's start with the very first one, that is under the hydrocarbons. All right, so beginning with the very first group, we have alkane, alkene, and alkyne. Now, as you can see, I've highlighted a distinct letter in all the 3 groups. You could see that for alkane it's A, for alkene it's E, and for alkyne it's Y. Hence, arranging them in alphabetical order, it becomes AEY. So AEY. Assigning numerical values to them, A is denoted by 1, E is denoted by 2, and Y is denoted by 3 in the series. Now, A denoting 1 simply means that alkane over here has a single bond. E denoting 2 simply means that alkene has a double bond, and Y3 simply means that alkyne has a triple bond. So that's the very first strategy. So alkane, the A there, 1 shows that it has a single bond between its carbon to carbon atom. So like this. Now, bear in mind that this part just bears R groups. When we talk about R groups in organic chemistry, they are simply, they simply denote the rest of the molecular structure, the rest of the molecule. Do you get it? And they are simply alkyl groups. When we talk about alkyl groups here, alkenes that have lost a hydrogen atom. So they are simply alkyl groups like methyl, ethyl, pentyl, and all that. and or they can be hydrogen atoms. So for the sake of the trick, I wouldn't be writing this R groups more often. It will be some of them that will be bringing the R group inside. Good. So let's move to the alkene. So for alkene, a double bond between the carbon to carbon atoms, and that for alkynes, a triple bond between the carbon to carbon atoms. So that's the very first trick. AEY 1, 2, 3 in that order. Now, still under the hydrocarbons, we have the aromatic hydrocarbons. Now, aromatic from the word aroma. Aroma just smells, and these smells, they circulate in the atmosphere. So I pictured aromatic hydrocarbons as something circulating. So they would start at the point and go back and end at the same point. So they are kind of circular, so cyclic, in a cyclic form. So I memorize that one so simple, that they are cyclic. So like this. So it starts from here, this part, moves all the way to this part, and ends at that same part. So aromatic hydrocarbons are cyclic, and they are bonded to an R group. So any part of it can be bonded to an R group, either here, there, here, or here. Any parts can be bonded to an R group. So aromatic from aroma, and aroma circulates in the atmosphere. So they are cyclic, they circulate. So let's start with the next group. That's the oxygen-containing compounds. That is organic compounds that have oxygen in their structure. For this particular category, we have the mnemonic CICA, as I said earlier on. So CICA. Now, this is a quick way to remember the groups that belongs to this particular category. Now, there's one thing to note about this particular group. Most of them have the same basic plan, with the exception of ether and alcohol. So as you can see, I've highlighted ether over here and that of alcohol. So these two have different structures. So I'll talk about them first. So ether and alcohol. So alcohol and ether. Now for alcohol, as you can see, I've highlighted OH here. So whenever you write alcohol or you spell alcohol, the OH in alcohol signifies that alcohol has a functional group of OH bonded to an R group. So OH, and there's an R group of which the OH is attached to it. Do you see it? So there's a quick way to remember alcohol. There's OH in the middle of alcohol. So OH bonded to the R group over there. Good. For ether, this is how I remembered it. Ether looks similar to this English word, either. So there's basically an oxygen atom with R groups on either side of the oxygen atom. So R groups on either sides. So that's how to remember it. Now, as I said earlier on, for the CICA, we have only two groups that have different structures. But the next groups, that's the next four groups, they all have the same basic structure. So that makes the strategy a bit easier. So let's tackle them. We have ketone, aldehyde, carboxylic acid, and ester left. Now, what's the basic plan? That's the general plan for all of them. And the basic plan, the basic structure for all of them is actually a carbonyl group. So this is a carbonyl group. As you can see, a carbonyl group is simply a carbon atom double bonded to oxygen. So this is a carbon atom double bonded to oxygen. So that's a carbonyl group. So all these four groups, the ketone, the aldehyde, the carboxylic acid, and that of the ester, they all have this same basic structure. So ketone with this, aldehyde with that, carboxylic acid with this one as well, and that of ester. So for ketone, this is ketone. Now ketone has simply two R groups, so ketone is very simple. Now, ketone, key, looks like a key. So this structure over here with complete R groups at the end will look like a key. So that's ketone. For aldehyde, aldehyde is a ketone with a hydrogen atom hiding from the oxygen. And I got that from the ending, the hide, the HYDE. So HYD is for hydrogen and HYD is hide. So a hydrogen hiding from this oxygen. So obviously you have the R group at the other parts and a hydrogen hiding from the oxygen atom. For carboxylic acid, it looks confusing a bit, but trust me, it works perfectly. For carboxylic acid, the carbo content means that the CARBO part simply means that it has a carbonyl group. So this is a carbonyl group and an alcohol component. So the R group is obviously found here, and this part contains an alcohol component, so an OH. So the R group and an OH. So that's for carboxylic acid. And finally, the ester. Now, ester is simply a carboxylic acid that has lost the H attached to the O over here. So I say ester. Ester is kind of similar to Easter. So let's say it's Easter time and your mom buys you an egg. So what's this egg? The egg is simply oxygen bonded to the final bond over here. So aside the R group here, we have an oxygen atom over here like this. And that oxygen atom is also bonded to another R group over here like this. So that's ester. Now the next category, that is the nitrogen containing compounds. I also have a mnemonic over here, that is NAA. N for nitrile, A for amine, and the last A for amide. So this compounds, that is this organic compounds, obviously contain nitrogen. Now for nitrile. Now nitrile, as you can see, I've highlighted some letters. N simply means that there's nitrogen in there, obviously. And I have TRI, tri. Tri means 3. So the strategy is this. Nitrogen triple bonded to a carbon atom. So nitrogen triple bonded to a carbon atom becomes nitrile. Very simple. For amine, you can see the N component, obviously meaning that there's a nitrogen in there. Now you know this the AMI over here. It looks like you're spelling ammonia, but it's incomplete form of ammonia. So ammonia is NH3, right? So if it's incomplete form of ammonia, that means there's nitrogen in there. But since it's incomplete, it wouldn't be NH3, but instead NH2 bonded to an R group like this. So the NH2 bonded to an R group will be the amine. Now for the last one, the amide. Amide is simply the DE part makes amide different a bit. So amide over here, a quick way to remember is that amide has a carbonyl group. So we need a carbonyl group. And since it has the AMI component, it will borrow this NH2. So it borrows it over here. It brings it here. So attached to the NH2. So this is the functional group of amide. A carbonyl group with the amine content. That's the NH2. That is it. So for the very last group, that's the supplementary functional groups. We'll talk about alkyl halide. As you can see, I've highlighted some parts, the HAl components. So that is the main part that can be used to identify this functional group. And the HAl sounds like halogen. When we talk about halogen, they are simply groups 7 elements. So fluorine, chlorine, bromine, iodine. So those two groups 7 elements. So simply an alkyl group attached to a halogen. That is this particular functional group. So this is the alkyl group attached to a halogen. So the X over here signifies the halogen, the chlorine, bromine, iodine. The next one we're talking about is an acid anhydride. So an acid anhydride. And this one looks funny anyway, but it works perfectly, as I always say. For the acid anhydride, I picture it as 2 soccer players with a ball in their middle. So, you know, this one of the soccer player, this another soccer player with a ball. See, sounds funny. So the soccer players I'm talking about are actually carbonyl groups. They look like soccer players. So this one soccer player, another soccer player with a ball in the middle. It looks exactly like this picture. Not really, but a way to identify this particular functional group. We can use this as a means of identifying what type of functional group is present in the compound. So an acid anhydride, 2 soccer players with a ball in their middle. So this is this. So 2 carbonyl groups with an oxygen atom in their middle. The very last one we're talking about is a thiol. Thiol. I'm talking about thiol. Now, thiol, I've highlighted the TH part. So it's simply an alkyl group bonded to, if it was to be correct, it would have been an alkyl group bonded to a TH. But you know, in the alphabets, S comes before T. So a way to remember is that anytime I see the T is not accepted. So I just replace the T with an S. So it's just an alkyl group that's an R component bonded to SH. So the T is replaced by S, which is sulfur. So R bonded to, that's the R group bonded to a sulfur and a hydrogen, is simply thiol. Now you know TH and SH, those two things actually can be used interchangeably. So it works perfectly. If you've been able to deduce your own mnemonic or strategy for learning functional group, you can drop that in the comment section to help your colleagues as well.